Hack Sprint. Today we're going to be going over advanced views, and yep. So as always, here's the link to the slides and the README. So if you would like, you can feel free to follow along and take a look at those. As always, we have our feedback form for Raffle Prizes. I would highly recommend signing that up because you do have the chance to win the raffle. And I'd like to emphasize that it is a raffle for like every session. So, you know, if you keep filling it out, then like, you know, there's a pretty high probability that you would at some point probably be able to win something. So yeah, please fill that out when you can. And if you haven't, we still have our Hack Discord where we post announcements and you can ask questions and basically just, you know, collaborate with other people who are also in Hack Sprint. So I would highly recommend joining that if you haven't already. And as a project update, if you signed up to work on a project this quarter for Hack, then please look at the Hack Discord because we have created a channel that specifically pertains to that. So that's where we'll be posting more information. And yeah, so that is something to keep note of. All right, so what we're going to learn today is advanced views. Here is, you know, the whole layout of this entire quarter. And today's topics are going to include arrays and lists, navigation view and navigation links, protocols, ScrollView, and MVVM. All right. Again, our note on coding along is, as always, we encourage you to try out, you know, the things that we discuss in the workshop and teach you in the workshop, but coding along might not be the best because we do go at a somewhat faster pace. And I know from experience that it's really hard to like, you know, try to follow along something while you're also doing it at the same time. So it's much easier, you know, to just kind of vibe right now, like just listen to the information and then you can definitely try it on your own later. And again, you can always ask questions if you are confused in the chat. So feel free to do that. Okay, today's app is going to be called, I guess, the Chipmunks. And basically we're going to have a layout here of you know, a bunch of different items, and you're going to be able to click on one of those and enter kind of like a new screen. So to begin with, we're going to start with talking about arrays and lists. So what is an array? Well, an array is basically a Swift data type that we can use that will hold things. It holds types of data. So whether that be, you know, a string, ints, you know, any data type that Swift offers, you can store that inside of an array. And there's a couple caveats to this. It can only hold one type of data. So you can't have an array that's, you know, partially strings and partially ints. All of them have to be the same type. And there's a couple different ways to declare it. So this first example here, I use the let variable, which if you remember means that it's constant. And you can declare it just by outright, you know, writing out every single item within the array, or you can use the var variable and create an empty array in this case. So for this second example, this would be creating an empty array that is string type. And you might want to use that if you're not sure at the moment what you want to put in the array. And later you might want to populate it with something. And yeah. So some important things to note about arrays is that the indices of an array always start at 0. So this might be a bit confusing at first, but what this basically means is we start counting at 0. So if we had this array here called chipmunks, then we would basically have at position 0 would be Alvin, and then position 2 would be, or position 1 would be Simon, and then position 2 would be Theodore. So we always start at 0 for that, for arrays. Okay, so iterating through arrays. There are ways to iterate through arrays, and you might be wondering, like, why would I ever want to iterate through an array? Well, basically, iterating through an array makes it really easy for us because say you wanted to print, everything in array inside of an array. You don't want to go manually type out, every single line in there. That's gonna take a lot of time, and your fingers are probably gonna hurt. You'd probably be mentally stressed. It's not very healthy, but there are certain things that we can do to basically make that process easy for us. So for Swift in particular, there's two main ways to do it. The first one is this method called for and then in. So what does that mean? So say, we have an array here called numbered chipmunks, and it has these 3 items, 1, 2, and 3, and those are all strings. So what we can do is we can say for chipmunks in numbered chipmunks, print chipmunks. So you might be wondering, where did this, initial chipmunks come from? Well, that's basically a variable that we create. So it doesn't need to be called chipmunks. It could be like, anything that you want. It could be called squirrels or like, even just like but basically this tells Swift, oh, hey, we're going to go over every single item in the array and then do whatever's in here. So in this case, when we run this particular section of code, it would print 1, 2, and then 3. And a second way to do this is by using the for each command. So what this does is it basically takes our array and it says for each and passes in chipmunks, which again is a variable that we created. And if you remember, that's also a closure, which is basically telling the program, hey, we're passing that in, and it's going to print chipmunks. So that would do the same thing as the previous example. So now might be something that you aren't as familiar with, and it is called a list. And a list is somewhat similar to an array, but they're not really the same thing. For Swift, or Swift UI, I should say, because a list is a Swift UI term. A list is basically what makes a list pop up on the screen of our app. So in this case, I have an example that has 2 text views. The first one is Pog and the second one is Eugene. So when we actually put that inside of the list, you can see on our preview, we would have one item as Pog and the second one as Eugene. And this is different from an array in the sense that a list, is a Swift UI element. So it makes it show up, whereas an array is more for just storing data within the program. And here's a bunch of examples of lists in real life. So, our settings app, you can scroll through that. Every single one of these, from airplane mode, Wi-Fi, Bluetooth, etc. Those are all items in a list. Same thing with the Notes app, or even like, the dining hall menus, like those are all lists. And the list goes on. All right, so very quickly now, we're going to recap some things because they're going to come into play pretty soon. So remember structs. What are structs? They group related data together. So in this example, we have a struct called person. So, a person structure might have a bunch of unique attributes to it, including a variable called name, a variable called age, and one that's occupation. But basically what this is saying is like it's keeping all those together conveniently under this big blanket statement of person, rather than just leaving those scattered throughout our code. And instances, another recap, is basically an occurrence of a struct or a class. So it's something that has its own unique values. So a chipmunk instance, for example, might have the name assigned to it as Alvin, but another one might be called Simon. And it's important to note that we're not actually changing like the overall, I guess, definition. Like we're not hard coding, Alvin or Simon into the structure that the instance comes from, but we're just making a new instance of that struct. Okay, so the reason for these recaps is because they are somewhat important to know how to pass an array into a list. So you might have made the connection that hey, an array holds data and a list shows like, you know, a column of items on our screen. So that makes it very convenient for us to basically take an array and throw it into a list. And how can we do that, you might ask? Well, basically, we are going to use our list or our array, I'm sorry, as a parameter for the list. And then we're going to basically use a closure. So in this case, for an array chipmunk list of chipmunk instances, we use the array called chipmunk list as the parameter. And we use the instance chipmunk as a closure. So for this particular example, what would be happening is it would go throughout the entire list and print out every chipmunk instance's name. And the closure is necessary just to, you know, tell the program like, hey, we're dealing with these chipmunk instances. So, you know, be aware of that. So that's so it knows like where to go to get that information. Okay, so to do this, there's a couple of steps. If I can just, you know, break it down. So the first step is we need to create the struct for the instance in the first place. Then we need to create an array of those instances. And lastly, we actually pass the array into the list. So rather than just keep talking about it, I'm going to actually demo it for you. So let me see. Okay. Let me know if there's an issue with the share screen. So I'm aware. But basically what I have here is a demo app. And, you know, as you can see, we're starting with just hello world. So this is what you would see if you just booted up, you know, any normal or any new Xcode project. So the first thing I'm going to do is I'm going to create a struct for let's say chipmunk. So how I'm going to go about that is I'm going to say struct chipmunk. And keep in mind, this is outside of the struct content view. This is, we're creating a new struct, so we don't want to have that inside each other. Struct chipmunk, and then I'm going to say identifiable. And you might be wondering, what does identifiable mean? Well, for now, we will discuss that even further later in the workshop. But for now, understand that identifiable is this thing called a protocol. And what it's saying is it's basically letting the program know, hey, we're going to make a struct that's going to be, you know, used somewhere else. And every instance created with this struct is going to have its own unique attributes. So like, you know, just be cool with it. And yeah. And if we did not, you know, put this identifiable in, then Swift would, it would kind of blow up at us. And one more thing that unfortunately we did not talk about yet, but we will kind of get into later, is we have to include this let ID equal UUID. And this is basically assigning every single new instance of a chipmunk to have a unique ID of its own, which again kind of aids the program in just being like, hey, you know, this is its own unique thing. So now we get to like actually create some variables of our own. So I'm just going to say let name be a string, and let's say let description be a string. So every chipmunk instance is going to have its own name, and it's going to have its own string or description. Cool. So the next step we need to take is we need to declare our array. So what I'm going to do is I'm going to say, let's see, var chipmunk list, and I'm going to make it type chipmunk. So remember, chipmunk is this thing right here that we just created. And I'm going to say now that's equal to, whoops. So if you remember, this is kind of fitting the format of one of our array declarations. And I'm going to say a new chipmunk instance as the first object, or not object, first item. And I'll just say, let's let this name be Alvin. And for now, I'll just keep the description blank because I don't think anyone wants to see me type out a whole description of what Alvin the chipmunk is. Oh no, my dorm. I have a lamp. Actually, if you guys just like give me a second, I can go turn on the light really quick. My bad. They have these timed things. Okay, my bad. I do not know why they have a timer for the lights in the dorms. It's kind of a bruh moment, if you ask me. But okay, where were we? Second item of the array. I'm going to say this one's name is Simon. And again, I'm going to leave the description blank. And we'll say the third one is Theodore. Again, with a blank description. Okay. So I do not know why there's an error. Let's see. Can I? Oh. Whoops. Wait, did I make a typo somewhere? Chipmunk. Yay. All right, no errors. Okay, so now we have finished our second step, which is creating an array full of these chipmunk instances. So the last thing, the last thing is we finally get to, make this show up onto our app. So what I'm going to do is I'm going to get rid of this hello world, and I'm going to create a list. Whoop, why is it not typing? Oh, list. And I'm going to pass in chipmunk list as our parameter, as we showed before. And remember that we need to include this closure of chipmunk in, which is basically letting the program know, yo, all of these things in the list, they're going to be chipmunk instances. So, be prepared for that. And if I were to just, say text chipmunk.name, then if I, resume this live preview, it should show up. There we go. So as you can see, we just created a list of 3 items. First one's Alvin, second Simon, third Theodore. And what's happening here, again, to recap, is we're basically printing this text view of chipmunk, so a chipmunk, instance, and we're getting the name of each unique one. So the first unique one is Alvin, second Simon, third Theodore. Okay, great. But we don't really want to just have, a list of the chipmunk names. Let's say we want to spice it up even more. We want to, get descriptive. So what I can do is I'm going to press Command on my Mac, and I'm going to click text, and this really convenient, pop-up just shows up, and I'm going to embed this into an H stack. And what we can do is, if we had images we wanted to use, so say I wanted to have an image of my boys, my homies, Alvin, Simon, and Theodore, right next to their names, we could, if you have, an image, get those. So I have already prepared, Alvin, Simon, and Theodore. I'm going to take those and just drag them into my assets. All right, there we go. So now those are in our assets, and notice that each one's name is like their actual name. So, Alvin, Simon, and Theodore, that's a bit important for what we're going to do right now. So if we just, insert the image, instead of needing to actually look at what each one's actual name is, we can just do chipmunk.name, because what this is going to say is oh, for each chipmunk instance, let's get that name, and we'll put that into, the parentheses of the image. And then this will say, oh, let's get that image that's called, for example, Alvin. So when it goes to the assets, it'll see, oh, there's an image called Alvin. Perfect. And then it will show up. So unfortunately, I believe if I resume this, it's going to be a bit messed up. Yeah. So it's like, it's because the image itself is not really in the dimensions of the app. So I've already tested this before. So I have some view modifiers that I know will make it look like how I want it to look. So I'm just going to insert those now. But if you're doing this on your own, you can definitely mess around and see which view modifiers make it look like how you want to make it look like. And follow your dreams. So if I did this, oh, typos. Yay, we have, our boys there. And of course, I could always do a little bit more. I can say, oh, let's say I want to, center the text. I can put a spacer before the text and a spacer after the text. So now there's, equal distance after the image and after their name. And I'm just going to add really quick a font to this just so it pops a little bit more. Okay, cool. I think it's important to keep in mind all of this stuff is just formatting, but the real new stuff that we covered right now was, creating the array, creating the instances within the array, and then actually, passing that stuff into a list to make it show up. Okie dokie. So I'm going to go back to slides. Okay, and now we're going to cover some more new stuff. So we have a list, but we can't really do much with it. No one just wants to look at a list, or at least I feel you can do a bit more with a list than just look at it. So there's this thing called a navigation view, and a navigation view basically lets you go into other views in a sequential path. So this is kind of like, changing screens. And some IRL views, there's on Instagram, there's a home screen, there's a profile screen, lots of screens. This is my Instagram, by the way. It's at james._.woo. I do follow back. So, feel free to look at that. And something important to note about navigation views is navigation view brackets hold the current view. So whatever's inside that original, whatever formatting you have inside the initial navigation view brackets, all that stuff is confined to like that view. But we actually change views by using what's called a navigation link. And this tells the program where to go. So if we had a navigation link that's called, or I guess this example of a navigation link, what would show up on our screen is some text that says click me. And if we clicked it, it would take us to some other view that's established in the code called other view. That would have to other view would have to be something that you set up earlier. Otherwise the program won't know what the heck other view is. So why is this important? This is because this allows us to enable more features and overall, better control the user experience of our app. It lets things be easily categorized. So rather than, if we had a description of Alvin, instead of just throwing that all on one box, we could make, a navigation view of a list. And then once you click that list, it would take you to some other screen with a description. So you could, you wouldn't even be limited to Alvin and the Chipmunks. You could expand the Chipmunk multiverse. Okay, so now we have a poll coming up about, all the stuff that we were just covering. So I'm going to be launching that in just a bit. Okay, so take some time to look at that and fill out what you think is the best choices. Okay, I'll maybe wait like another 30 seconds to a minute for people to to finish answering this. So please, get your answers in. Hopefully it's not incredibly challenging. Okay, I'm going to end the poll in 3, 2, 1. All right. And I'm going to share results here. So let's go over this one by one. So it looks like for number 1, the majority of people chose the last option as their answer. And the correct answer is the last answer. So now let's talk about why. So this second choice here, which was actually the only choice that other people chose, like arrays, lists are bound to only holding one data type. So the thing about lists is they are more so used for views. So, you could put any type of view that you want in a list. You could put H stacks, V stacks, any stack. You can put text in it, whatever, and it'll just spit out like a nice looking list. Lists don't really hold data types. Arrays are the ones that more so hold data types because arrays are Swift elements, whereas lists are Swift, or arrays are Swift elements, whereas lists are Swift UI elements. And it, as for the correct answer, yes, it is possible to declare an empty array with a specified type. And you might want to do that if you're unsure about what you want to put into the array at the moment. And yeah, for number 2, excuse me, a navigation link can redirect to a navigation view, but a navigation view cannot hold a navigation link. True or false? So the answer for this one is actually false. A navigation link is contained by a navigation view. And it's true that a navigation link can redirect to a navigation view, but you always put a navigation link inside of a navigation view, because that lets the program know, oh, hey, we're on this view right now. And once you click, this link, then we can switch to something else. So be aware that you do need a navigation view to contain a navigation link. Okay. Okay. Let's see.
I'm gonna start sharing now.
Okay, yeah, we can trade off.
Okay, give me one moment. Okay, let's see. All right, perfect. Okay. All right, hello everyone. So now we're going to continue and adding on to what James has presented already about navigation views. As we noticed, we'd like to also add a title to it. And so far we haven't talked about how to add a title to our view. And this is going to be using this modifier, this view modifier called navigation title. And all this will really do is add that, for example, the chipmunks title to our navigation view and to our list. And the reason why we might do this is to reduce ambiguity about the options. So if we didn't put the chipmunks there, users might not know what if they were unaware, or in like maybe a different situation, they might need to know what those options are and where they might be redirected. So it's helpful to have a title for our navigation. So let's do a demo with navigation view, navigation list, and see how we can get that set up. So I have the app open currently. Just the only thing I will point out that I changed is that I added some descriptions here, which will come into play later. But we don't have to worry about that too much about the actual content we're going to be adding for now. So what we can start with is by wrapping everything inside of the list with a navigation view. And what this will allow us to do is be able to click on any of the options within the list to navigate elsewhere. So within this chipmunk list, actually, we're going to wrap the list in that as well. So we're going to do a navigation view. And put our curly braces. And right now, Xcode is trying to create the second screen, but let's put this in together. And right now, we'll see the list as we did before without much going on. Now what we'll do is add our links. And if you remember, our navigation links are going to be the actual, I don't want to say buttons, but the actual things we're going to click on with our finger on the phone or with our mouse while we're testing it to be able to redirect to a different page. So we want to be able to click on anything in this list to be able to go to the next page. So what we're going to actually do is put all of this content as the label for that navigation view. But let's just start off with a little bit of a simpler example. So within the H stack, each one is going to have a navigation link. And we're just going to put the label, as we saw in the slides, click me. And our destination is just going to be, let's just say that we're going to put some text in here. And where this will take us is text, hello, hello there. Okay, so this doesn't look like much now, but if we go ahead and click on this live simulation and click here, it'll take us to a different page that says hello there. And any one that we click on will display hello there. Of course, this is not what we want. If we remember on the slides, what we want it to display is the name, an image, and the description of each chipmunk. So we can start enhancing this by changing up what we show in navigation view. So first of all, I'm going to change this by removing this click me label. The reason we want to do this is because I don't want to have text there that says click me in this case, because I actually want the users to be able to click on the chipmunks themselves to be able to go to their descriptions. So I'm going to remove that label for now. And I'll just put this on the same line. But what I want to add now is an actual description label. So we're going to be explicitly defining the label and using using a closure, we're going to put all of the views that we had there otherwise inside of this closure. So I'm just going to drag and drop everything that's here currently and put that here. Okay. So this looks a little bit better now because while it still has the same functionality, we don't have some label on the left that's obstructing the original display of the view. All we have is the chipmunk image and their name and the ability to click and go to a different page. Cool. And now let's exploit the, just for making the code pretty, I will put that on the same line. Okay, and now something we're going to exploit, which is a weird word, but we're going to put the navigation title on this navigation view. So I don't want to put it on here, but I'm going to put it right here on the list. So we don't want to put it on the navigation view content. Usually we put it on whatever the navigation view holds. So we're going to do navigation title and put the chipmunks. Cool. So as we see now, we have this title that says the chipmunks. And what's really beneficial about this is that if we click on here, the redirect button no longer says back. It says the chipmunks now. And this can be kind of helpful in case a user gets lost and they don't know what they just clicked on. They can go back and view it again. Yeah. So we're just going to do a couple other things to make this, I guess, to prettify it. What we're going to do is make sure that this text is going to be on the same line. So I'm just going to change some of these values just to fit the way that we have it set up now. And these are values that I found that worked ahead of time, which is why I'm choosing these values. but you may have to play around with them. Like actually that's what I did to figure out which values work best. Okay, so all I'm doing is just changing the font size to something a little bit smaller and making the images a little bit smaller as well. Okay, cool. And just to reiterate, this still has the same functionality, but we want to be able to go to a page that shows the chipmunks instead of just having hello there. So actually what we'll do is create a new view, and I'm going to put this on top of here. So we're going to say struct and then profile sorry about that. So we're going to chipmunk profile view. And I'm just going to put the same things that would normally come with the view, which is just this var body. And don't worry about what that is, but all the default views start up like this. Oh, actually, sorry about that. I'm going to put this aside for now because instead, sorry, I made a mistake. I'm sorry about that. Instead of actually creating another view for now, what we're going to do is actually, I want to showcase that we can put we can actually use this closure again to kind of personalize the pages. So like make it for the chipmunks. We can actually do it in here. That was my mistake. Sorry about that. So let's just start again. What we want to display is the name, the image, and then a description. And we actually know how to do all of that. What we're going to use is a VStack. And all we're going to put is text chipmunk name. So this will put the name of each chipmunk, the image. And just to clarify, the reason why we put chipmunk name again is because the name is what we've used to define these images. You see each one's called Alvin, Simon, Theodore. So we can reference the images with that name. And then finally, we can have a chipmunk description. Okay. Don't know what those errors are. Chimpanzee. Oh my God, I made that same typo again. Sorry, I did the chimpunk typo that we had last time as well. Very easy typo to make, I guess. Okay, now if we resume the preview, what we can expect is the images to be a little bit badly sized right now. So we'll put view modifiers soon, but if we just click on it, we will see that now they are personalized, but let's just go ahead and style them because I don't like looking at really large chipmunks on my screen. So I'm just going to change the font size to this size. And I'm going to make the font bold. That's just the design choice that we made. So we're just going to bold the font. And now we'll need to resize the image because it's a little bit too big. So we're just going to mark it as resizable. Now we're going to change the aspect ratio to fill, which will just make it go up to the body of the area that we've defined, and then width. Oh, sorry. Width. Sorry, I'm getting a little bit distracted by my laptop fans. They're very loud. I don't know if they're picking up, but they're very loud for me. Sorry, this is content mode. Okay, and if you might recognize some of these view modifiers from previous sessions. So if they feel a little bit unfamiliar, don't worry about it. They're just commonly used view modifiers for changing the way that our views will look. Now, if we go ahead and click on if you go ahead and click, I do not know why the chipmunk is so big. Sorry, I don't want it to be that big. Maybe this size. This is live debugging. We're testing the sizes. I'm not sure why it's so big, but it's okay. We'll let it be that big. But as we see, we have the name, the image, and the description below. Okay. So I kind of went through a little bit of kind of a lot, but just to recap what we've added to James's previous code, we added a navigation link to be able to go through. We added a navigation view to be able to go to different pages, and then using the navigation view, we created a navigation link, which allows us to specify when we click on the things in our list where we will be going. Okay, now let's continue. So something that we saw before, but we didn't really talk about what it is. We have this weird identifiable thing there, including the ID too. We didn't really talk about that yet. So what exactly is identifiable? So we're gonna have another Swifty time. If you're at the last session, remember we're just little tidbits of Swift information that will come in handy for the future. Even though this whole workshop is not going to be just about the Swift language. Okay, so what identifiable is something called a protocol. And protocols are blueprints with functions, variables, and other requirements for some specific functionality. Just to play into the blueprint analogy a little bit more, protocols will only just define kind of what it's supposed to look like, just the general outlines. So as we see in this very lovely blueprint, and the credit to that is in the comments of these slides, we have like some libraries, some gates, a church, and other buildings that should be there, but this blueprint doesn't tell us how to build it. And essentially protocols are going to be doing that as well. They're just going to tell us that you need to have these, but they won't tell us how to actually implement it. So what I'm talking about is specifically functions and variables. Protocols won't give values to them or implement those functions, but they'll tell you that you need to have them. And just to call back to something, just in case you've ever used C++ before, maybe you're taking CS31 or 32 right now. It's sort of similar to the .h files that you may have created before, where you put all of the outlines of the functions, but you don't really specify them until your actual files. And if that made no sense to you, don't worry about it. That's just a little analogy for those who are aware and want to connect it to some other language that they've used before. So just to talk about protocols a little bit more, protocols are not only they're not only defined by Swift UI. And what I mean by that is that you can actually create your own. So while identifiable is provided by Swift UI, we can actually make our own protocols. And the way that we would create that is very similar to how we would create something like a struct or some other kinds of Swift things. So for protocols, we would just simply write protocol and then the name of the protocol, and then use curly braces to put what would be in there. So for example, for this protocol, we're going to have a can-fly protocol. And the function that anything that's using this protocol will need to have is go fly. We're not telling anything that's going to be using this protocol how to implement go fly, but they just need to know that they have it. They need to have it. And there's a link to some more documentation if you would like to get really, really in depth. But we're just going to talk about how it's applicable. We're going to go into it a little bit more, but just in case for reference. Okay, so we've seen this in our code already, but just to put it with our example of CanFly, you can show that something is following a protocol, and what the terminology we use here is conforming to a protocol. And that way, the way to do that is very similar to how we can specify types for variables. So if you remember for variables, just as an example below, we have var wingspan double with the colon. That's very similar to how we are going to show that something is conforming to a protocol. We're going to write the struct and the struct name. So we're just creating this struct eagle, which is a bird, and we're just going to say that it conforms to the protocol can fly. And we see here that the function, the struct eagle has the function go fly in it, and it will have some implementation there for what it can do. And just to show something else as well, that just because they conform to the protocol does not mean that's the only thing that they can have. So that's why, like, for example, we can add the wingspan to the eagle. Or in some other situations, such as our demo for the chipmunk, we can have other things that don't just apply to the identifiable. And we'll talk about what the identifiable protocol actually needs in a second. But you don't just have to have that functionality of the protocol. You can add other functions, other variables as well. So this is a concept that maybe if you've used C++ or some other what we call object-oriented programming languages before, you may be familiar with, is inheritance. And actually, Swift has this concept as well, although we didn't talk about it directly. So just to reiterate what I just said, we did not talk about inheritance when talking about classes, but you might have heard of it before, maybe while your time in CS32. If you've never seen this before, or Swift is your first programming language, don't worry about it too much, but just stay tuned for when we tie this into protocols, because we really just want you to understand protocols mostly. But we just want to make this differentiation just to anticipate anyone who might be coming from that C++ or other language background. So specifically, inheritance is like this relationship between classes of that's saying, the parent class is saying that you are of this type. So you directly are that type. So for an example, as an example on the slides, and if I created an omelet and it inherits from a breakfast item, then the omelet is a breakfast item. And it's sort of like how you are a human, just like your parents, you know. That's why the meme on the side. And whereas in protocols, it's not that you are that type. So the eagle can't be a can fly. What protocols are is more of something like a certification. So it's just a verification that you conform to, or you have those attributes of that protocol. For example, James, who presented before me, is really cool. So he may follow some protocol called cool, whatever that functionality or the variables are, if functions and variables apply to humans, he would be following those protocols. But he's not just a cool person. Like that's not all he is, right? But he has other traits as well. And that's the general idea of how protocols work. You aren't inherently that thing, but you have those attributes and those functionalities. And actually, before I move on, just want to say again, if you haven't heard of inheritance before, don't worry too much about the inheritance part of it, but focus on the protocol part of it. But if you have heard of an inheritance and might have been confused about what's the difference, this explanation was kind of just to demonstrate that. Okay, so some more on protocols. Structs aren't only limited to conforming to one protocol. So let's say we have some protocol called transportation, and the variable that they have is max passengers, and it's some integer type, so they can have that many passengers. As we can see, some struct plane can also have a can fly type, and can conform to can fly and can conform to transformation. So it doesn't just have to conform to one. And another cool thing is that the plane and the eagle really aren't like the same thing. So they don't fly in the same way. They don't have the same things. You know, another thing is that the eagle had the wingspan, and but the plane has passengers and like it's mechanical. But we can still apply it even though they're not the same type. And this really comes back to the fact that like the protocol doesn't define who you are, but it just gives you some functionality that you can say, hey, I do this, so you can trust that I do this. So for example, for the plane, it has the function go_fly that was required by can_fly, and it has the variable and implements that. So let's say the plane can have a maximum passengers of 500. It conforms to the protocol transportation because it has that variable. Okay. And yeah, just some final points. Note that a plane and an eagle can both fly, but they aren't really similar in other attributes. So we would rarely really classify these together. Sometimes we would prefer this instead of like a strict relationship that inheritance provides, like that strict you are this. Protocols don't really do that. So just to bring this all together to the reason why we really brought this up, well, of course, there's many reasons to use protocols in Swift, but our main introduction for you to protocols is the identifiable case study. So identifiable is a protocol, and what it ensures or certifies is that any structure or class that conforms to the identifiable protocol I just said what I was going to say again. Anything that conforms to that identifiable protocol has some uniqueness. And we saw that in the form of ID. So the identifiable protocol has this variable ID that anyone who's using that protocol must conform to in order to be certified that they are identifiable. And this meme is just there as a meme, but it's also really applicable, right? Let's just say that all of those Charmanders on the shelves are not identifiable because they have by themselves, we might not be able to tell them apart. They have the same makeup, the same price, the same all the designs on them. So we would not be able to tell them apart just by the visually. But if we assigned an ID to each of them, then they would be unique. But of course, the one sitting there with the dots instead of the full face is very identifiable. It's just a meme, but I thought that was very applicable as well. So yeah. It is the cutest, yes. Yeah, so going back to what we had before, if we don't have the required variables that are blueprinted by the protocol, so if we're not conforming to the protocol, then Xcode, or I guess in general, in general, Swift will complain about that because you're not conforming to the protocol anymore, and you're trying to certify yourself, and you're saying, oh, I'm identifiable, but you don't have the ID. So that's why we had to add that variable ID. And we used a function called UUID, which you don't have to worry about too much about the actual implementation and whatnot of that. But the general idea is that it creates a universally unique ID, UUID. And what that means is no other instance, even of any other object, no other instance will have that same ID. So that chipmunk that has that ID will only have that ID. That's the only one that will have that ID. So it's identifiable because it has that uniqueness through that ID. And that's how we know that chipmunks will conform to identifiable. And I can actually show this error in our code as well. If I go over here and just comment this out, so it's not there anymore, we'll get this error that we also see on the slides. And it says type chipmunk does not conform to protocol identifiable. And we see that here as well. It has some jargon here. Do you want to add protocol stubs? Some really funky Swift way of saying Xcode will add the variables and functions and whatnot that are required for you. But if we add the ID there back, it will work. So that's why we need that. But that's not the only time we've seen protocols, actually. We've seen protocols before, and that's with content view. Because content view actually conforms to the view protocol. As we see, we have struct content view and then the colons and view. And that's just really, really cool because it's actually inherent to the way that the entire skeleton code that they give us works. The view protocol, all it does, just to give some overview, ensures that anything with that protocol will have a body in order to display that content on the screen. So that var body is something that's required by the Vue protocol. So there might be some questions after I've been rambling for so long. I mean, is there a, oh, that's a typo, oops. Is there a reason we had to use this? Like, why are you complicating? Why am I complicating your lives by adding protocols? And what is the meaning of life? Some people might say it's 42, or I guess that's the answer to everything in life. But regardless, I can't answer that last question. That I don't know that either. But as for the other two, we actually really needed identifiable in that code. We didn't just add that for funsies, you know, just because it would be quirky way to introduce protocols. No, that's not it. We actually really needed identifiable. And it's actually for the way that we use lists in our code, we need each item to be unique. This is something we call a dynamic view, meaning that the content is not directly put in the curly braces. So our code doesn't know what will go there until we run the app. And the way that we see this is because we do the chipmunk in. So we're iterating through that array and adding it. So the code is not really there at that moment. And this is in contrast to something called a static view, which will already have like those set data values. So like if we put everything in there, like the text, image, etc, all like just put in those curly braces, then that would just be a static view. And we wouldn't need to have this identifiable. But since we want to iterate through the array and display each thing from that chipmunk, then we need to use identifiable. And while it may not seem like super important right now, since we only have 3 chipmunks, it's actually really great once you get like very long arrays or a lot of data values, or in the next session, we may see this come into sorry about that, come into play as well when we fetch, I don't want to introduce terms that we haven't talked about yet, but when we get like data values that we don't know we'll have yet in an array, then this will really help, since we won't know off the bat what will go in there. So just like TLDR for this slide, the list needs everything to be identifiable with the way that we're iterating through the array. Why is it doing that? Strange. So once again, Swift UI needs to be able to tell each item apart in order to ensure that all of them are displayed properly, or else it could be unpredictable. So if we pass the array in, the objects in that array, so the instances of chipmunk were not identifiable, then we couldn't ensure that all of them were displayed properly, because Swift UI won't know when to stop. It won't know, like all of the uniquely identifiable items have been displayed, especially if you have the same name and the same description. If we had the same name and the same description, especially in that case, Swift UI would not be able to know. So we need a unique way to be able to tell Swift UI that. So the protocol is promising the list that we're making each item unique, so it won't have any issues with displaying each item on the screen. And if we don't put identifiable, we would see some error like this in the code when we try to do. So this is just a simpler example with strings, and strings are not identifiable. So if we try to use that same thing on this string, we would get this issue that it does not conform to identifiable. But that's just an example of why we, like, just to prove the point that we do need it. And once again, just to restate the use of protocols, protocols help us with ensuring that anything that relies on the struct or the class. So for example, the way that we're using the list to go through that array, it relies on that chipmunk struct. So anything that relies on that struct can safely call its functions and be sure that there is an implementation for that function. So in our case, we can ensure that everything is identifiable. So list will know that the list will be like, hey, I was able to display everything that you gave me on the screen because I know that each one was identifiable and I know I didn't miss one. And I was able to tell everything apart. So yeah. So that was a lot of talking. So just a big TLDR is that we want to put the identifiable protocol on the structs with items that you use in the list. And this is not just unique to lists. There's something called for each, which we haven't covered, but that's just an FYI, that it's not only lists that need this. Identifiable is used very frequently. Okay, so that was a lot of content. So let's do a checkpoint poll just to see how everyone's doing with that content. I'm going to launch this poll and I'll just give everyone a minute just to fill it out. Just how was the pace of that? And yeah. Is there a third option for okay? Okay, well, it's not there, but you can answer that in spirit. Okay. Okay. All right. So I won't share the data of this poll. Just so like that everyone feels comfortable answering truthfully and everything. But this is really helpful for us to know how to speed up. So thank you for those who filled it out, or not filled it out. Thank you for those who answered the poll. I'm just going to end it now. And after all that talking, we're going to take a break. So come back at, let's put the time for 7:16. And I'm going to pause the recording for now. How do I pause the recording? Oh, there we go. Resume recording. So let's start with a poll about, but this time we're going to be going over protocols. So gave you some time to simmer over it. This will be a little bit short, but just feel free to take some time to just go over it and check and see what you think about protocols. Let's just give a minute or so. Okay. So just give another like 10 seconds just to wrap up. Okay, so let's go through the problems together. So share results. All right, cool. So first question was true or false? Each struct can only conform to one protocol. And actually the answer for this one is false. And if we go back a couple slides, is it going back? Yes, it is. Okay. If we go back to a couple slides back, we see that, yes, okay, this is the one. We see that the plain struct actually can conform to two different protocols, and all it has to do to conform to it is implement both of the like blueprinted like functions and variables from each of them. So the answer to this one is actually true. Or sorry, oh my God, it's actually false. Each struct can conform to more than one protocol. So yeah. Next question was, what would happen if you left out a function that was defined in the protocol's code inside a struct conforming to that behavior? And the correct answer is it would not work, since Xcode will complain about not following protocol. So the other highly picked answer was it would still work because you don't need to implement all of the variables / functions in a protocol. And this is actually incorrect. as we saw with the ID example with identifiable, if we don't implement the variables that are required to conform to that protocol, we will actually get an error, because in order to say that you conform to a protocol, you need to implement all of the variables and functions defined by that protocol. So just keep those in mind. And of course, don't worry if like it was a lot of content and you didn't like it, it's hard to remember it. You don't have to memorize it. But I'm just introducing it for now. So when you use it in the future, or maybe you might refer back to it, the slides to relearn it, whatever the case may be, just so that you had that exposure. Okay, so let's go. Stop. Okay, what is going on? Please let me. Okay, all right. Now I'm going forth. Okay, so let's go back and just take a look at what we have so far. So what we have is our list, which can navigate to different screens. But something that we see is that all of the description actually gets cut off at the end. And this is a problem because we have this like a lot of descriptions about the characters, the chipmunks, but we're not able to read them right now. So let's just say, again, just to reiterate, we have this really long description, but we can't see all of it. Like, please let me read about my bestie, Simon, like best chipmunk, by the way, Simon. Okay. So what if we could scroll, hint, hint, to read all of the text? And I know you're used to scrolling on TikTok, so don't lie. But following that hint, what we can implement is something called a scroll view. So a scroll view is a container view, similar to like how VStacks and all the stacks were. And the scroll view is a container that sets the content inside of it as a scrollable region. So for example, in this example GIF, on Rotten, like that's just like the Rotten Tomatoes website, there's a description of the movie and the user is able to scroll up and down to read all of it. And this doesn't just apply to text only. Of course, you can have anything in the scrollable region, but in this example, we're going to be trying to have a scrollable text region. And scrolling can be vertical or horizontal, horizontally aligned. So following that note, there's for vertical scrolling, which is the default, all we really have to do is have scroll view and then the curly braces, and then just whatever content we have in there. And it doesn't have to be all text, but in this case, I've just put a lot of text. And here's the Swift hack sprint motto that we have, unofficial motto, yeah, yeet Swifty feet. But the formatting is actually really similar to some other container views, i.e. VStack, HStack, and ZStack that we've seen before. And all we have to do to make it horizontal is add the parentheses and dot horizontal to it. And the scrolling will be sideways and the content will be aligned sideways naturally. So let's go ahead and apply that. There's really not much to this scroll view. So all we have to do is go over to where we have VStack and just change that to scroll view. And if we click here, now we see that we have this little Alvin with his image, and we can scroll up and we can scroll down. If you don't have an iPhone, the scrolling is typically allowed like this, so that we can just scroll up to kind of just have that functionality. And now we can scroll down as well. So now we see the whole description. So if we go to Theodore, for example, this is applied to all of them. So this is really great. Now we have the full functionality of our app that we were looking for. So yeah, that's actually all for implementing the app, but we have some more that we need to talk about. So right now, all of our code is just in this huge file. Like if I just go back very quickly, especially with like these descriptions put here, we have this huge file with all the struct and like the scroll view. And it's very hard to see like what exactly is going on. So like, you know, our file kind of looks like that, or our code kind of looks like that right now. it works how we want it to, but it's really, really hard to read as of right now. So what can we do about that? So last session, Eugene and Caitlin talked about extracting views. And to continue that idea of extracting views, we can use some model called MVVM. And what this stands for is model view model, which is kind of a very weird naming of it, but we'll see why it's called that in a second. So MVVM is one way to organize our data in our folder. And what we call this is a design pattern. So this isn't something like the Swift code requires you to use this at all. This is very much just a choice that you make, but it will only benefit you in the long run because it reduces the code complexity. And by that, what I mean is like all the stuff that's going on in the code, it's much easier to read since there's not a lot of views and a lot of data stuck all around. And we'll maintain a clean structure for our code. So it'll be a lot more legible in the end. And just to, oh, I did not mean to leave this here. We'll get back to that mean. We will get back to that mean. So continuing with MVVM, actually, the session 3 demos files, which are on GitHub, already separate using the structure. There's no view models there currently, but the model and views is already following that structure. So we'll be referencing this quite a bit, just because we want to give a shout out to all of the hard work that the Eugene and Caitlin put into creating that demo. But also, it's just a very good example since we haven't set ours up yet. We will be setting it up with this structure. Okay, so here's a very, very like bleh looking overview, but it kind of does the general job right now of showing us what's going on. So what we have is like the view communicating with the view model back and forth, and view model communicating with the model. Right now, those are just like some abstract terms. So let's get into what is actually classified in those. So let's start with view. So anything that goes in the views folder is code that formats the data. So like we're going to be using Swift UI to display it on the screen. So this data is actually the content that we see on the screen. Just again, referencing the session 3, we have like the content view, which we also have, and other things that were visible on that app. The actual visuals of it go into view. So you'll be using a lot of Swift UI code in the views folder. And data, such as structs and functions and arrays, aren't explicitly written here, but they may be called and used in here, which, that's the functionality that we have right now, is that we're using these arrays and structs in our code. But to make our code cleaner, we only put the visual things in views. And added on to that, we don't have to put everything in content view. We can actually take them out and put them in their own files and call them in content view, which we will do shortly. Next, let's skip view model and talk about model. So models just hold the data, really. You can kind of think of this as like the behind the scenes logic of the code. So it's not really what's going to be displayed on the screen, but rather the things that the data that controls what goes on the screen. So again, just using the session 3 demo as a reference, we have this game struct, and it holds all of that data in there. Something you can call back to is our chipmunk struct. That, for example, counts as data that isn't really going on the screen directly, but we use it to display things on the screen. It's kind of that behind the scenes logic, because the struct itself is not being displayed on the screen, but things that the way that we use that struct allows us to put data on the screen. So now hopping into view model, View models can be thought of as the link between model and view. So they have implementations of things outlined in the model. So the struct, maybe we create the data, for example, an array of objects of that struct, of instances of that struct, or maybe some functions that the view can use to update the things on the screen. This may really come into play once we get into next session, where we have functions that we can use that will get data for us. For our app specifically, this will pertain to the array, where we have implemented that struct with different chipmunk instances into an array. That is a view model, because it's not a view in the sense that it's not like actual Swift UI data we're putting on the screen, but it's also not the bare bones implementation like the struct is. And just to use this analogy of a teacher and a student, the view model, or a boss and a coworker perhaps, the view model will tell the view what to do. So right now we only have an array, but what else would go in there is like functions and other kinds of functionality. So the view model will use those functions, and when the view calls it, the view model will tell the view, hey, do this or do that. And this isn't necessarily going to be display things, which is why it's not a view, but rather they're just going to be data-wise things that the view can use to display its things on the screen. And okay, so it's very, very abstract right now, and it might be like a lot to take in, and that's okay, because we also don't have a lot of specific things going on. So it might not seem like it's very important, but as your code gets bigger and bigger and you have more functions and you have more data and more views, it becomes very important to have this. So just one more look at the way that they communicate. The business logic and data really refers to that model. So like all those behind the scenes things. The view model will use all of that like defined data and create functionality for those structs, for whatever we define, as well as like instances of those structs and whatnot in that model. And the data binding is very similar to the binding that we've seen with the in the last session. Really what this is talking about is that the view and the view model will communicate with each other about different variables and different functions, and the view model may do certain things to the variables we give it from the view. And the view will read that, see what's happened to it, and display it. So one thing that you might be asking is, I can read my code, so why would we do this? Especially, maybe you might be asking this about this demo as well. You might be like, okay, sure, maybe the array description has a lot of info, but the rest of it's not too bad. And sure, okay, maybe it may be readable on a small scale, but once the code gets a lot larger, it will be really difficult to manage and read. And like the term for this is that it won't be very modular. Like having everything in one file, it just makes the code a lot less readable. So putting chunks of code in different files allows for a more clear view, no pun intended, of what each view, struct, function, array is meant to do, and what it represents, and what group of functionality it really belongs to. So what it's like, we can clearly see what it's meant to do. And this meme that I accidentally left in earlier, but I meant to show now, is kind of just like a representation of this. Like once we have really chunk code, so to speak, it'll be like something like spaghetti code. So it'll be very, very messy. But our MVVM may be something very neat like this, like a pizza. And so it'll be very, very easy to, I guess we're not really eating the code, but it'll be very, very easy to read the code, use it. And especially if you're working with other people, it's really great to have easily readable code, because not only for your sake, but for anyone else who might be working with you or might be reading it, it's good to know. And it's good to be able to see what's happening in the code. Okay. Here are some asides that will, two of them to be exact, that will come in handy for this. So dot constant is related to the bindings we learned last session. So in case you might have forgotten what bindings are, make sure to review from the last session. But it'll just for this demo, just as a quick overview, we're going to be able to pass our data from view to view. So what we're going to be using here is dot constant, and this dot constant binding is something that we can use instead of the $ variable that we used last session to pass a binding that will not change. So the properties of it will not change. Our chipmunks will have the same values, so the same name, ID, and description that we may give another view, because we define that way. We want Alvin to have that image and that description. So we will use this to create a binding to a value that does not change. And we'll see how that comes into play. That was just a quick aside, just so that's not, when we type it up, that's not the first time you'll be seeing it. And the second aside is that when we create a Swift file, we will see a line that says import foundation. And it's not too important what that means right now for us. But in case you're curious, foundation is what allows us to use basic data types. It's the foundation of our code. So arrays, text, and other fundamental types are provided by foundation. And then there's a lot of other like essentials it provides. And feel free to, both of these slides, I've provided some quote unquote documentation for it. That feel free to read it and see what it's about. But this is just an aside, not so much that not so much that it all has to make sense right now. It's just that I don't want when we're coding things up for that to be the first time you see it. Okay, so let's get to implementing MVVM. So right now we have everything in this file. So what we can do is create 3 folders, okay? And how this is created is through this new group on Xcode. So just right click on our project folder and click new group. So we'll create one called views, and one called models, and one called view models. Okay. All right. So first things first, we can start with our views. So let's drag our content view in there, and I hope this still works. Okay. Dang it, it's giving me that very weird error again. Okay. Normally content view would be able to go in there. I can't recall why that error is happening. So in this situation, we will not be putting in there, but typically you will be putting content view in the views folder. I was unable, this is a known error. I was not able to figure out why. Just for transparency's sake, I wanted to mention that. But just know that it is supposed to go in content view. But let's move on to another view that we can extract. So let's analyze this code a little bit, actually. So we have this content view here. This needs to stay in this file because that's really what the content view is for. Then we have this array of each of our chipmunks and descriptions. This isn't a view, but this is some data that we'll be able to use. And you may start thinking of where it might belong, but for now we're going to ignore this because this is not a view that we can extract. However, once we take a look at this main body portion, we'll see that we have this list and a navigation link and some labels. Now, what we're going to extract from here is going to actually be this view that we're going to jump to. If you recall from the navigation link slides, we can pass into this destination here a view that the navigation link can jump to. And this is really great because we're extracting this view. This view isn't really in, this profile view isn't really in the main page. It's something that we actually navigate to. So it would be really nice if we could take this out and put it in another function so that we don't cloud all of the code that's going on the main page, all of the views that's going on this main page. So what we can go ahead and do is create a file. And when we create this file, you want to go ahead and click Swift UI view instead of Swift file. And reason for this is because once this launched, and I'm going to make this called Chipmunk profile view. And once this comes through, we'll see that it provides all of the skeleton code that we can use to really put the views in there. So this looks like its own its entirely own view, and it is, but it's callable from the other page. So quite directly, what we can do is like start messing with this, and like, you know, just to show that this is its own view, we can just type some other things like profile. You know, we didn't put a VStack there, that's why it's on two screens, but nevertheless, that is its own view, separate from the content view. So what we can do is take this scroll view out and put it in here. Now, of course, we have an issue with this, right? What is this chipmunk? This view does not know what this chipmunk is. And now we can call back to our, sorry. And just to complete this code here before we move on, we would put chipmunk profile view here instead. So we're calling this view, this new view that we've created, but there is an error here. This chipmunk does not know, this chipmunk profile view does not know what chipmunk is. This is something that we've defined here. So what we need to do is use some of our knowledge about state and bindings from the last workshop and create a state variable that we can pass around here. So what we'll do is create this is weird. This is very weird. Sorry. What we'll do is create a variable here. It will be a binding variable so that we can pass a variable in here called chosen chipmunk. And all this is saying is that we're going to be asking for this chipmunk, and whatever it gives us will be this chosen chipmunk, and we can display that. And so what we can go ahead and do is put chosen chipmunk name here, here, and here. And all we have to do now is actually pass this variable in. So if we go over here, what we can do is use our dot constant. So chosen chipmunk is dot constant. So we're going to be passing this binding variable that doesn't change, and it will just be what chipmunk is. Okay, and if we go over here, we can do dot constant, and just to explain a little bit of what this is. Chipmunk profile views, or this preview, is what we see on the right hand side here. So all this isn't going to be in the final code, but this is just so for preview's sake. So what I'm going to do here, and I won't get too in depth on this, is what I'll do is just in this preview view, I'll just create a preview chipmunk and we can use this chipmunk list here up here and index into it and just grab some chipmunk to display. So really the only reason we're doing this is because we want to be able to preview something on the page. And so I'm just going to display some chipmunk here, and I do have to provide that binding variable here as well in the preview. Otherwise, it will be very confused. So I'll do preview chipmunk. And if I do resume, Okay. I might have messed something up, and I apologize for that. I really apologize for that. I don't. Okay. I don't know what's happening. So okay, that went away. But I'm really sorry about that. I don't know what's happening with this code. That it's oh oh my gosh, oh my gosh, I forgot to put view there. Wait, please edit that out. um what uh I I'm so sorry. I messed this up. I messed this up big time. I'm so sorry, everyone who's here live. Damn. What? Sorry. What did I? Oh, there was. Was that intentional? I've never seen this before. I'm so sorry, everyone. I really want to make this work for you all. I'm really sorry. Trying to.
Do you mind
figure
checking
out-
the parentheses or the braces really quick?
Sure. Okay. Oh, you know what? I think it's missing the bottom level. I might have taken out an extra one. Um. Ah, thank you so much. Okay. Oh my gosh, I was getting worried there. Thank you. I do wonder if I can drag this in or if this is going to cause another. Okay, that's still having that issue. Okay. Okay. At the very least, I don't know why this error is occurring either. Okay. Okay. To avoid that for now, that's not gonna work.
I think that one is because you're declaring it in a different, or the chipmunk list is in a different struct.
Oh, is it? Okay.
Right now, the chipmunk list is inside your struct, right?
Oh yes. Oh yes. Oh geez. Thank you. That is meant to be outside. Okay. Oh my gosh, there's so much to cut out. I'm sorry. Uh. Um. Oh, it's constant. Okay. Whew. Um. Oh my gosh. Okay. I. Dang. Why it's throwing all these? Oh my gosh. Sorry. After one error, my brain shuts down. Okay. I'm so sorry about that, everyone. I'm really sorry. Okay, so getting back into it. Okay, let's just pick off where we were supposed to leave off. Every single profile view. Now we can like preview it, and it's been extracted. So now we can view this, like kind of play around with it in this view. But now, most importantly, we can call it from over here, and be able to. And now the code isn't like filled with a lot of the view code that was there before. And of course, if this other page had a lot more code, then that would be an issue, because the code just over here would be a lot longer. So already we've done that job. So as far as views, that's all that we will add. But let's talk about models now. We have this struct here called chipmunk. And as we talked about, the models will be things like data, kind of that behind the scenes logic. And it's not the implementations yet, but rather just the structs, the actual struct itself. So we can put this chipmunk struct into its own file, And what we'll do is create a new file and do Swift file. And we'll just going to call this chipmunk. As opposed to the other ones, we don't put view at the end because it's not a view. It's just a chipmunk struct. And here's the foundation that we saw earlier, just so you weren't too surprised. That's why I wanted to mention that earlier. Okay. So now we put the chipmunk struct here, and our code is already looking a lot better. Now, there's one final thing, and it's the view models. And remember, this is really the implementation of our struct and what the views can use to call to do certain functionality and whatnot. So while we don't have any functions, what we can extract is this giant array with instances of the chipmunks. So I'm going to make a view model called chipmunk view model, and we're going to create a new file, and this is also going to be a Swift file, and it's going to be called chipmunk view model. Okay, and all we have to do is extract all of this and put that in here. Cool. So while this file, of course, is a little bit chunky, we have greatly changed the outline of this struct. This content view, the main views. All of the views are just what that functionality is meant to do. All this is about showing the profile. All the content view is the main page and all of that functionality, all of that data that we're seeing on the screen at that page. And it still works like before. So that's really expected. What all this did is make our code a lot nicer, and without costing us having such long code, and without costing us the functionality. So that's really just a very basic example, but just an example of how you can apply MVVM to your projects. And it becomes more applicable, especially with very, very long projects. Okay, so back into the demo. We're just going to have a short poll. And this one will just be a review of ScrollView and MVVM. And I'll just give a couple minutes for this one because it's a little bit longer. So feel free to go through it and take some time. Yeah. Just gonna give another 30 seconds for this one. Okay, cool. Let's go over the poll answers. So I'm going to end the poll and share results. So first question is, why do we use MVVM? And the answer to that, and everyone did get it right, is it helps structure the code into an easy to read fashion, but it's not required. So as we mentioned, it's just a way to structure the code and make it more readable. But yes, it's not required by Swift UI or Swift or even Apple themselves. Second question is, does ScrollView add new content to the screen? And the hint here was think about the difference between container and content views. And we talked about this a little bit back in the first session with the difference between stacks and the other views such as text and image that we talked about. And the correct answer is no, because ScrollView just is a way to add some scrollable region and structure the code, but it's not visible content on the screen. It's just some of the container functionality. And last question is, what is the purpose of ScrollView? And the correct answer here is to add a scrollable region to possibly view a long section of content. Of course, the section does not have to necessarily be off the screen to add that scrollable region. You can scroll through things that don't go outside the screen, but it is mostly used for those out of the screen, off the screen regions. And just to go through the other answers, it does not provide any navigation by itself. It is just adds a scrollable region. So it can be used in junction with the navigation view. That is to say, it can be in the navigation list. The navigation links as the destination, but it does not redirect to another page by itself. Okay, great. And I know you're all tired of polls, but we just have one more checkpoint poll, and that is just to see how the speed of that last section was going. And I'll just give like 30 seconds for this one, just to. And also, I really appreciate you guys sticking with these polls. Okay, I'm going to just end the poll now. Thank you for the responses. That was the last poll. So just to wrap everything up, what's next for views? So in this workshop series, so far, we have not covered every view that might come in handy, but luckily you have the tools to learn more. And notice how, like, when we were learning about navigation views or scroll view, we saw a need in the functionality of our app. Beforehand, we researched it and how to implement those navigation view and scroll view and found that those views would be helpful. And you can do that as well. So if there is views that we have not covered yet that might add some functionality to the app, you may find it in the documentation or elsewhere, and similar to how we've presented this content. So while it is definitely a learning process, above all, it's really just about having fun and learning new things and just taking your code to the next level. So yeah. That's all for this workshop. Thank you all so much for coming out. Next session will be next week at 6 p.m. On Zoom again, and we'll be talking about data and networking. Please fill out the feedback form. We really appreciate it. Plus, of course, there's a raffle. And you might, like, out of the people here, you might be one of those people who actually do fill it out, and you might have a really good chance of getting some money. So yeah, please fill that out. Thank you so much for coming. Especially thank you to those who got through some of the technical difficulties on my end. And yeah, have a good Wednesday night.